Welcome to your video on ordering positive rational numbers. Today you are going to compare and order positive rational numbers using the conversions you know, your prior knowledge on writing fractions, decimals, and percents as equivalent values in varying forms. So the question is, how would you know which is a larger ratio when given varying fractions, decimals, and percents? So here we have three different numbers that have the same digits, but they have varying values. Okay, so some things that you're going to need to know are that greater than symbol is like this, less than is like this, and you can remember that because you read them left to right, and equal to, and then number line is used to put numbers on, and it can have varying intervals. So I could have a 0 and then just go by ones, or I could go by 1/2, and so on and so forth. What I need though is I need these to be in the same form to be able to compare them. You might be able to make some predictions. You might be able to tell, hey, 7/8, I know that's less than 1 whole because it's not 8 out of 8. I might be able to tell that 8 7/100 is greater than 1 because I have an 8 in the ones place. And 87% is less than 100%, so that's also less than 1. So right away, based on those predictions, I might be able to tell that this is the largest. But I still need to know, what if I want to put them least to greatest? I'd have to know which of these is the next in size. So some options are just to change them in the form that you feel most comfortable in. So I might want to change them to decimals instead, or I could change them to fractions. I know that 7/8 can't be converted to be out of 100, so my most comfortable scenario here might be to change them to decimals. So divide this. I know that this is the same as 875 thousandths. And I know that from practice, but I could just do 7 divided by 8 goes into 70 8 times for 64. 6 left over goes in there 7 times for 56. 4 left over goes into 45 times. That's just but that's one of those ones that I've memorized, and that's okay to do that also as long as you know how you got there. So these are equivalent numbers. Whereas then I know that 87/100 I read as 87/100. Oh, so these are fairly close. Notice the only difference here is my thousandths place. So to know what those would be, I could check on rounding, or I could just fill in my thousandths place with a 0, and then I could tell 875 thousandths is greater than 870 thousandths. So a really important piece for comparing fractions, decimals, and percents is getting that common denominator. Common denominator is going to be super helpful. If two people have pizzas and this person says that they just ate one piece, they ate right here, and this person says that they ate one piece, that's not necessarily the same. It's important that we have them out of the same denominator. So what I could do, yes, this 1/2, but it's also the same as, if I were to cut that again, it's the same as 2/4. Whereas I can see here, this person only ate 1 of the 4. So now it's easy to see that this person ate more of that pizza. We can't just say 1 piece. We want to say out of how many. So that common denominator is going to be super helpful. You can just use that as the least common multiple. Okay, so we're going to fill in the blank to make sure that the sentence is true using less than, greater than, or equal to make sure that the sentence is true. So here I have 4/5 compared to 7/8. So I may not know these automatically, so my showing my work would be that I either change them to percents or decimals. In this situation, I'm going to want to use my division. 4 divided by 5, 7 divided by 8. And I know that it's going to be less than 1. So 5 goes into 40 8 times. And then that's done. So this is equivalent to 8/10. 7/8, like I did in the last one. I know that it goes into there 8 times for 64. And again, I've done this a couple times now, so that's why it's so quick. 7 times for 56. And then it fits into 45 times. So I see that these are equivalent to 8/10 and 875 thousandths. If it makes me feel better to do some double checking, I can always fill in with zeros on the end. and I can tell that 800 is less than 875. So 4/5 is less than 7/8. Here I see a decimal and a percent. I know it's super easy for me multiplying by 10 to go change from a decimal to a percent. I multiply by 100, not 10, sorry. Or change from a percent to a decimal, it's dividing by 100. So that's just 2 decimal places to the left or to the right. So here I may take this times 100 to make it a percent is 12.5%. And I know that 12.5 is greater than 10 2/10. 5 43/100, and then 5 2/5. So this one I know is a fraction that is easy to make to 100. So I might just leave this one the same. And again, my way is not always the right way. These are just the things, it's how I visualize numbers and how I see them most easily to me. You might do them differently or change them to a different form, and that's okay. Just get comfortable with the numbers and figure out what is best for you. So here I know I can multiply these both by 20, and this is the same as 5 40/100, or 5 40/100 as a decimal, so I can see that 5 43/100 is greater. Go ahead and pause at any time and give these a try on your own. 5/6, I'm going to change that to a decimal, so I'm going to do 5 divided by 6. 6 does not go into 5, but it goes into 50. Let's see, 6 times 6 is 36. 8 times for 48. 2 left over. 6 goes into 23 times for 18. And notice now I'm going to continually get 20 left over. So I know that my 3 is going to repeat. So right now I can tell my 83/100 with the 3 repeating is greater than this. Even though this has more digits at the end, we have to go what's getting closest to 1, and we can see 8 is getting closer to that 1. So that's greater than. 30%. 30% and 1/3. Again, this might be one of those memory things. We start to get used to what they're equal to, and that's good. These are good things to memorize. 1 divided by 3, but it's still important that we understand how they are what they are. 3 does not go into 1. It goes into 10 3 times for 9. And we are going to continuously have a leftover here of 1. So that means this is repeating. So if that's repeating, that's going to continue. Whereas here, 30% we know is 30/100, which is also the same as 3/10 or 30/100. So we can see now that 0 is less than 3. So we know that 30% is less than 1/3. Last one, we have 35/100 and 3/8. So again, I might write this as 35/100. Maybe I compare it as 35%. Either way, these are all equivalent expressions of a number. 3/8 I may decide to divide, because I might estimate right away, and I can tell that this is less than 1/2 because 4/8 is 1/2. So I know it should be less than 0.5, so it could be close. So 3 divided by 8. 8 goes into 30. Not 4 times, almost messed that up. That's okay, mistakes are part of learning. 3 times for 24. 6 left over. 67 times for 56. 4 left over goes into 45 times. So this is equal to 375 thousandths. So I can see this number, if I fill in with a 0 on the end, 350 is less than 375. So 35/100 is less than 3/8. Again, none of those ways are the only way to do them. That's just how I, going quickly, think about numbers, or what makes easy for me. Doesn't mean it's always the easiest or the best way. So now I may want to write my answers in order from least to greatest rather than just comparing them with symbols. So you can convert them, but your answer should be in the original form. So if I change them to make them easier to look at, I still should change them back and write them in that order. So here I have a fraction, a decimal, and a percent. These look fairly close already, so I might just do some quick changes, maybe multiply this by 100 to change 2/10 or 20/100 to 20%. And this might be one that I just know. I know that 1/4 is the same as 25/100 or 25%. So ordering them least to greatest, it looks to me as though 0.2 or 2/10 is less than 22%, which is less than 1/4. If you're not sure how I'm doing anything, make sure you write down questions to bring to class. So then here I have, noticing this is greater than 1. This I know 100% is exactly equal to 1. And here this is less than 1 because it's not 9/9, it's less than that. So I'm ordering these least to greatest, and I can already tell based on what I know and using my estimation. So I know that 8/9 is not quite 1 whole, so it's less than 100%, which is equal to 1 whole, which is less than 1 2/10, which is greater than 1 whole. So again, talking through these things is super helpful in making sure you understand it. Here I can look, right away I can just be able to determine which one's the largest. All of these are less than 1, whereas 2 4/10 is greater than 1, so that's my largest. 40% I know is 40 hundredths, which is 4/10 or 40 hundredths. Wait, I just said 4/10, and that's the same as 4/10 here. So these are actually equal, so I can put them in the middle and it doesn't really matter the order. This one people get mixed up on a lot. This is 4 hundredths. 4 hundredths is less than, you can tell, 40 hundredths, so that is my smallest. Then the other two can go in, and they're actually equal, so least to greatest. One more here, we have 11/4, so I know that's more than 1. All of these look like they're more than 1. So it looks like I might just have to convert these to decimals to be able to tell, to see what whole number they are, because I can tell 3 is greater than 2. So this is really just like division. This is 11 divided by 4. Well, 4 goes into 11 2 times for 8, and then there's 3 left over. And I could continue with a decimal, which I probably should because these are, or I could do, that's 3 out of 4 left over. So that's one option. Or to show you the decimal, what I do. So I know it's 2, should be over the 1. Wasn't very neat with that. And it was 8, 3 left over. Goes into 38 times. Just kidding, 7 times. I'm messing up. See? That's okay. 7 times for 28. 2 left over. Goes in there 5 times. So notice I got an equivalent either way. So I can tell that's larger than this. And then last one, 13/5. 13 divided by 5. Or you can look at it like this. Really what you're doing is saying 5 goes in here 2 times with 3 remaining, but now it's 3 out of the 5, so 3/5. Or if you can continue with your decimal instead, 2 and bring my 0 down, 6/10. And if that's confusing, again, go back, rewatch, slow down. So that's equal actually. So these two are equivalent. So we know that those are the smallest, 2.6, 13/5, those are the same, and they are less than 11/4 and 3 1/10. So last thing, putting these numbers on a number line, if you're putting them on their least to greatest, we see our number line as intervals from 0 to 5, and there it is, 5. And so again, you might want to convert them to numbers that work for you. So I usually tend to go to whatever I see the most of. So here I'm really comfortable with these decimals. I can see this is greater than 1. So I might know right away. Let's see what this is by 5. So this might be 1, 2, 3, 4. It looks like we're going by halves here. So in between each half then, so if this is 1/2 or 0.5, that means that there are 1/10, 2/10, 3/10, and 4/10. There's 4 of those between each one. So that's good to know. So that when I want to put out 6/10, that's 1 after the 1/2. So that's my 6/10 there. 3 and 2/10, I know that's 3 whole numbers. And then 2/10 in. So that's right here. 3 and 2/10. 40%, again, I might want to write that as a fraction. I know that's 40 per 100. Or in this case, that's 4/10, which is also the same as 4/10. So that's going to be right there, 4/10. Or I better write it as the original amount so I know what that is. So that is my 40% of 1 whole. Because remember, all these numbers, fractions are based off 1 whole until you get larger. And then we have 1/2, which I already named right there. And then 5 and 5/2. So if we simplify that, that's really 2 divided by 5. Or sorry, geez, I'm messing up left and right, but that's okay. 5 divided by 2. 2 goes into 5 twice for 4 with 1 left over. So that's 2 1/2 right here. So I put 5/2 in the original amount. And then 24/8. I know that 8 goes into 24 3 whole times, so that's 3. And I might mark that there as 24/8. So it's kind of a messy way to do that, but notice I labeled all of the ones I started with. They're all written down here. And I just put them in order, and I made it easy for me to understand by putting them into tenths because I knew this could be broken up by tenths. So doing what's best for you. So don't forget, you can rewatch this video or watch someone else's. You could use, if you checked out a textbook, go back to some examples in there, or your target checks. You just have so many resources to be your best self. You can learn anything if you choose to.